Have you ever felt that horrible sinking feeling when a mechanic hands you a diagnostic bill for over $1,000 and all they did was plug a scanner into your dashboard? Well, if you have, then you understand exactly why so many people are desperate to find a way around dealership prices. Millions of drivers try to avoid this pain by using a free 30-second reset trick that forums absolutely swear will fix your transmission. And you know what the craziest part is? It actually works. You drive away, your car shifts smoother, and the throttle response gets crisper. But what 99% of drivers do not realize is that this famous trick is not actually touching their transmission at all. Instead, it is skipping the real fix and quietly letting a massive engine problem destroy their car from the inside out. Now, obviously, I am going to expose exactly what that 30-second trick is actually doing, and I am saving that massive myth bust for number one at the very end. But before we get there, we need to go through the 11 authentic reset methods that actually save you thousands. Because if you want to understand why that trick is a lie, you first have to understand how your car's memory actually works. So let us back it up for a moment. Your car is not just running on fuel and spark. It is running on memory. Every single time you drive, the engine control unit, which is basically your car's main brain computer, is watching everything. It tracks your coolant temperature, your intake air, the throttle position, and oxygen sensors every second. Your car constantly adapts to your driving style, the local altitude, and physical engine wear. It is always learning, and it stores this information in two completely different types of memory. The first one is volatile memory. Think of it kind of like a whiteboard. If you cut the battery power, that whiteboard gets completely erased. Your short-term fueling adjustments and pending codes live here. But your car also has non-volatile memory. This is a permanent record. It is where your long-term fuel calibrations, Immobilizer security keys, and permanent fault codes live. This type of memory does not care if you disconnect the battery at all, because it is specifically designed to survive a total power loss. And remembering this distinction is crucial because it explains perfectly why half the internet's reset tricks do absolutely nothing. Oh, and here is one fast rule before we begin. Stop erasing your diagnostic evidence. Before resetting anything, always photograph your scanner readout and record the freeze frame data. Technicians love owners who document baselines, and they hate owners who clear codes 3 times and erase the evidence pointing to the real problem. So with that out of the way, let us start climbing the ladder, beginning with number 11. Number 11 is battery registration. Now, nobody is making viral videos about this, but skipping it is a massive mistake. You see, modern vehicles have something called a battery management system, which is the software that controls exactly how much charge goes into your battery. Over time, it slowly reduces the charging rate because it knows the battery is getting old. So if you swap in a new battery without telling the scanner it is new, the computer aggressively overcharges it using the old, degraded profile. And because of this, you end up destroying a brand new battery from day one. But wait, there is more. A healthy battery actually stabilizes your entire electrical network. Your alternator, which is the part that charges the battery while the engine runs, naturally produces small electrical pulses called ripple. A strong battery absorbs those pulses and keeps the voltage smooth for your sensitive electronics. When a battery gets weak, it can no longer do this, and it creates voltage drops that cause control modules to randomly reset and send garbage data to the engine computer. So when you experience flickering gauges or erratic displays under engine load, it is usually just a dying battery making the computer hallucinate. Please do not replace expensive sensors blindly. Instead, go utilize the free battery and charging tests offered at most auto parts stores. They measure your battery's internal resistance, which shows how healthy it is inside, and your cold cranking amps, which is how much power it can deliver on a freezing morning to start the engine. Getting your electrical foundation right is always the very first step. And that brings us to number 10, the check engine light protocol, which most drivers handle completely wrong. Step 1 is simply to not panic. Step 2 is to check your gas cap. I know it sounds ridiculous, but a loose cap triggers an evaporative emissions code, and that tiny mistake causes millions of unnecessary shop visits. Just tighten it, drive for a few days, and the light often turns off by itself. But if it stays on, remember step 3. Never replace a part just because a scanner threw a code for it. An oxygen sensor code does not mean the sensor is actually dead. It could be an exhaust or vacuum leak. Take the 2005 Mazda 3 owner who spent hundreds replacing sensors and injectors because they were chasing a persistent code. Well, the real culprit turned out to be a tiny, cheap purge solenoid. Scanners tell you what system is upset, not what physical part is broken. But what if the light stays on and your scanner shows absolutely 0 codes? There are usually 3 reasons for this. First, cheap scanners simply cannot access manufacturer-specific modules like the transmission or body control. The codes definitely exist, but your scanner is completely blind to them. Second, intermittent brief glitches can trigger the light without ever meeting the threshold for code storage. And third, random engine control unit software glitches just happen sometimes. So if your scanner shows nothing, you really need a professional tool that queries all the networked modules. Finally, remember that a steady light means you can drive cautiously to a shop. But a flashing check engine light means active, damaging misfires are destroying your catalytic converter right now. A steady light means drive cautiously, but a flashing light means pull over immediately. Number 9 crosses into professional territory. Tools like FORScan for Ford or VCDS, which stands for VAG Com Diagnostic System, for Volkswagen are full diagnostic software suites that can actually reach deep inside your transmission. Sophisticated automatics, like the famous ZF 8-speed made by a German company called ZF Friedrichshafen, are constantly learning engine torque outputs and adjusting clutch pressures to match. So if your engine runs poorly, the transmission overcompensates, and that is exactly what creates those clunky shifts. A simple battery disconnect cannot reach the transmission module to scrub this data, which is why you need a professional tool. The Ford 10R80 transmission perfectly proves just how complex this gets. After clearing the adaptives with FORScan, Ford demands a very strict relearn drive cycle. You have to perform light throttle accelerations from a dead stop. You have to ensure upshifts hit strictly defined speed ranges. And then you climb to 55 miles per hour before executing specific braking, neutral, and reverse patterns. Repeating this entire cycle 7 times thoroughly repopulates the fast and slow adaptive tables. It works beautifully on healthy components, but it falls apart completely if you miss even one step. But here's the craziest part. The exact same reset that fixes one car can break another. For instance, if you clear the transmission software on an Alfa Romeo Stelvio, the lower gears instantly shift a lot firmer. So owners highly recommend cycling through every single drive mode right after the reset. Otherwise, the computer only learns one driving style. Meanwhile, Ford Ranger owners constantly combine FORScan clears with throttle relearns and structured drive cycles, and this combination perfectly fixes their mismatched torque expectations. But Land Rover and high-mileage Volvo owners consistently issue a massive warning about this. If worn mechanical parts are the real reason for your harsh shifts, erasing that software will destroy your drivability. You see, the computer was carefully compensating for the broken parts. Strip that software band-aid away, and you expose the raw mechanical failure underneath. Genesis G70 owners add yet another layer to this. Many of them experience lurching downshifts while stopping. Dealer resets produce temporary improvements, but assertive driving makes the transmission rapidly relearn that aggressive behavior all over again. In fact, in some 2022 3.3-liter turbos, a software bug actually bleeds aggressive shifting across drive modes. So a software update, not a reset, is the only genuine fix. Volkswagen Golf communities stress another critical distinction. DSG-equipped Volkswagens require VCDS resets perfectly paired with full fluid and filter services. Applying a DSG reset procedure to a standard non-DSG automatic is dangerously inappropriate and genuinely causes harm. Hybrids change the rules entirely. Mercedes A250e owners often complain about delayed upshifts holding gears up to 6,000 RPM in hybrid driving mode. It feels entirely broken, but it is completely intentional. The higher engine load actually generates surplus energy for battery charging, so in hybrids, erratic shifting is often a necessary feature, not a fault. Finally, some resets demand absolute factory tool authenticity. If you replace the CVT valve body on a 2015 Mitsubishi Outlander Sport, and CVT stands for continuously variable transmission, which is a beltless type of automatic, a battery reset does absolutely nothing. You have to use Mitsubishi's proprietary software to download a coding file that precisely matches the physical serial number stamped on the new valve body. Now, while those transmission replacements lock you into using dealership software, number 8 is an absolute crisis that happens right in your own driveway. It is the idle relearn. You disconnect the battery, and suddenly your car idles so violently it feels like it is stalling. The engine shakes. But do not panic, because your car is not broken. It is just relearning. Modern gas pedals use electronic drive-by-wire systems. Over the years, carbon builds up inside the throttle body, choking the air passage. So your computer slowly learns to open the throttle plate slightly wider to compensate for the dirt. Resetting the computer instantly deletes those compensations. And because of this, the throttle slams back to factory settings that demand a perfectly clean engine. Since it is now in the wrong position, the car barely runs. Now, there is one critical rule before attempting any relearn. You absolutely must keep your hands completely off the steering wheel and keep every electrical accessory switched off. Turning on the air conditioning or moving the power steering creates transient hydraulic and electrical loads that totally confuse the computer's adaptive logic, and that mistake permanently ruins the baseline. So the computer needs a secret handshake to relearn idle. Subaru requires turning the key on for 15 seconds without starting, then idling for exactly 10 minutes with all accessories off. For aftermarket LPG converted Subarus, which means vehicles converted to run on liquefied petroleum gas, this sequence is quite literally the only way to stabilize the idle. The older 2.0-liter Ford Zetec takes an easier route. You just reconnect the battery, idle for 1 minute, then drive normally for 10 minutes. And whatever you do, never touch the manual idle screw. Honda demands that you hold engine speed at 3,000 revolutions per minute until the radiator cooling fan kicks on, proving it reached operating temperature, and then you idle uninterrupted for 5 minutes. And Nissan is easily the craziest. You literally need a stopwatch. You have to press and release the gas pedal exactly 5 times within 5 seconds, then hold it down until the check engine light blinks a specific pattern. If you miss the timing by just 1 second, you have to start all over again. Because those manual relearn procedures are so frustrating, millions of drivers try to take the easy way out. And that brings us to number 7, the infamous battery disconnect myth. Everyone always says that disconnecting the negative cable instantly fixes everything. But the technical reality is that capacitors inside vehicle electronics can hold residual charge for a very long time. So for a reset to actually work, you must leave the battery disconnected for at least 15 to 30 minutes to allow those capacitors to fully drain. But remember our volatile memory lesson from earlier? Pulling the cable only wipes the volatile whiteboard. Sure, you lose your radio presets and short-term fuel trims, but deep long-term engine adaptations and permanent codes survive completely untouched. This is exactly why disconnecting a battery makes an older Toyota Shift smoother, but leaves a modern BMW entirely unchanged. BMW intentionally locks almost all of its learned behavior inside non-volatile memory, specifically to survive power loss. So a disconnect just gives you the annoyance of resetting your clock with absolutely zero diagnostic benefit. This also perfectly solves massive forum debates. People ask why a full battery disconnect improves performance, but pulling just the engine control unit fuse does nothing. It is actually quite simple. Some computers store trim values in memory that is only cleared during total vehicle power loss. Pulling the fuse leaves other modules energized through shadow circuits, which totally prevents a true wipe. Oh, and if you want to preserve your radio and memory during a battery swap, you can use an OBD2 memory saver. OBD2 is that standardized diagnostic port under your dashboard where mechanics plug in their scanners. Just make sure to avoid cheap, unfused savers, because if the positive lead touches grounded metal while the negative is open, you create a very dangerous short circuit. And never disconnect a battery while the engine is running, because it triggers massive low dump voltage transients that will instantly fry your electronics. Number 6 is the one system where you really need to put your tools down and step away. I am talking about the Immobilizer. When your security light flashes and the engine cranks but refuses to start, absolutely no magic pedal trick is going to save you, because security keys are locked inside deep, permanent memory. A Volkswagen owner once swapped an engine computer from a wrecked donor car just to save money. The car started for 2 seconds, realized the security keys mismatched the dashboard, and permanently immobilized the vehicle. He actually had to physically mail the modules to an expert for EEPROM cloning, which is a process where a specialist reads the raw security data directly off the memory chip and copies it onto the replacement unit. You really have to respect the Immobilizer. Sometimes desperate owners resort to software deletes, implanting live transponders near the ignition, or, like one infamous Mazda RX-8 community, splicing directly into starter solenoid feed lines just to blindly bypass cutoffs. And while these definitely restore operability, they permanently compromise theft deterrence, void your warranties, and create massive insurance complications. Treat bypasses as absolute last resorts. Number 5 features an intense enthusiast debate. Should you completely disable transmission adaptive learning? Well, Ford F-150 owners argue that disabling it forces a perfect static shift every time, effectively preventing the computer from learning bad habits. But automotive engineers strongly disagree. Adaptive learning constantly compensates for fluid degradation and clutch wear, so if you turn it off, the harsh, unadapted shifts rapidly accelerate internal destruction. Car enthusiasts eventually realized a dark truth about this. Shifting problems that feel like software glitches are very often physical hardware failures, just like worn CDF drum bushings, which are small metal sleeves inside the Ford transmission that wear down over time. So if you mask a hardware failure with aggressive tuning, you just ensure the transmission violently tears itself apart. Tuned vehicles require incredible caution anyway. A naive battery disconnect can sometimes restore stock calibration maps that completely wipe out your expensive custom tune, which is why tuned Ford owners rely on the SCT-KAM reset instead. SCT is a popular tuning brand, and KAM stands for Keep Alive Memory, which is the volatile data your engine computer uses for its real-time adaptations. It provides a targeted volatile memory wipe that clears adaptives perfectly while keeping the custom flash tune completely untouched. This separation is absolutely critical. And while BMW XHP transmission flashes, which is a popular aftermarket software that reprograms your transmission's shift behavior, definitely offer firmer, more responsive shifting, pushing clutch pressures beyond factory tolerances only accelerates wear in aging automatics. So the smartest approach is absolute mechanical soundness first. Fresh fluid, new filters, and healthy solenoids. Hardware always comes before tuning. But if your hardware is absolutely perfect, tuners sometimes deploy an advanced technique called the Vishnu reset, named after the tuning company that popularized it. Instead of letting the computer slowly adapt to normal driving, they combine a memory wipe with immediate, aggressive, high-load driving in specific RPM bands, meaning they hold the engine at particular revolution ranges. This forces the engine control unit to rapidly learn highly favorable ignition and load history, and this aggressive tactic seriously accelerates performance gains. But if your mechanical setup is even slightly marginal, this aggressive advancement will absolutely expose your engine to dangerous detonation, which is when the fuel ignites at the wrong time and can literally blow holes through your pistons. Now, every single rule states that no tool methods can ever access your transmission module, but number 4 is the single exception: Mazda. Owners have a bizarre manual procedure that actually commands the Sky-Active transmission to clear its own internal clutch adaptations completely without a scanner. Owners simply turn the ignition on, shift from park to neutral to drive in a specific rhythm, and pump the gas. This manual sequence magically returns the transmission to pristine factory learning. Mazda is legitimately the only mainstream brand on Earth to program a manual backdoor directly into the transmission. Not Honda, not BMW, not Ford. And that rare exception perfectly exposes the biggest lie on the internet coming up in trick 1. Number 3 is a really simple maintenance habit that routinely outsmarts $1,000 scanners. Before attempting any software reset, just clean your throttle body and mass airflow sensor. A $10 can of throttle body cleaner completely removes the carbon, and now the computer does not need to constantly recalculate its idle baseline. But the mass airflow sensor, or MAF, is even more critical. If even microscopic dirt sticks to the delicate sensor wire, it underreports the intake air. The panicking computer dumps massive excess fuel in response, and that creates horrible fuel economy and violent misfires. If your car is running terribly, try unplugging the MAF entirely. The ECU, your engine control unit, will instantly fall back to a safe, pre-programmed estimation. If the engine instantly runs better unplugged, you just forcefully proved that the sensor was lying. A 2002 Nissan Patrol owner actually used this logic for a massive power loss. Instead of throwing expensive parts at it, he inspected it really closely. He found a heavily contaminated MAF sensor and a tiny intercooler oil leak caused by engine cover friction. He patched the leak, cleaned the sensor with proper fluid, and correctly reset the computer. And full power returned instantly. If you truly want to see inside your engine's brain, you absolutely must understand your fuel trims. Short-term fuel trim is the rapid, real-time correction your computer applies multiple times per second based on oxygen sensor feedback. Long-term fuel trim is the permanent baseline memory the computer learns over time. It is literally just a percentage. A positive 20% means the computer is desperately dumping fuel to fight a massive air or vacuum leak. A negative 20% means the engine is choking on excess fuel. When professional technicians see high positive fuel trims, they do not blindly replace parts. Instead, they use smoke machines to visually expose cracked intake manifolds, or they spray propane gas around vacuum hoses. If the short-term fuel trim instantly spikes richer, they know they just found the exact location of the invisible vacuum leak. This data also reveals exactly when modifications fail. A 2012 Ford Fiesta owner installed a cold air intake and straight pipe. Instantly, his long-term trim plummeted to negative 40% at highway speeds. The computer was violently starving the engine because the aftermarket airflow dynamics completely confused factory sensors. Cleaning sensors did absolutely nothing. The new hardware itself broke the mathematical baseline. But when you read fuel trims, you stop guessing blindly. But when people cannot figure out their fuel trims, they very often do something desperate. Number 2 exposes the darkest side of mechanics. Hardware defeats. Failing catalytic converters cost $2,000. So desperate owners buy $10 metal oxygen sensor spacers that physically pull the sensor backward out of the direct toxic exhaust stream. It breathes clean ambient air, the check engine light magically turns off, and the owner feels brilliant. But you actually fix nothing at all. The crumbling converter still chokes the exhaust, and the engine now bases its fueling decisions on a complete lie. Hardware defeats just mask catastrophe. You should never replace a catalytic converter on a code alone. You must perform physical diagnostic testing first. Check the tailpipe for sulfurous, rotten egg exhaust odors. Measure the temperature differential across the catalytic converter casing to prove it is actively catalyzing gases, and perform exhaust back pressure testing to detect if the internal ceramic substrate has fully collapsed. Furthermore, you must analyze your fuel trims in context with both your upstream and downstream live oxygen data, because exhaust leaks and violent misfires easily trigger false catalyst efficiency codes even when the actual unit is perfectly healthy. Replacing it blindly without exhausting these physical tests is simply an agonizing financial mistake. But defeat devices are not always scams. The Chevy Volt coolant sensor failure famously caused endless service high-voltage charging system lockdowns. Unable to afford the forced dealer reprogramming, brilliant but desperate Volt owners physically installed defeat plugs or manually monitored coolant temps just to bypass the lockdown. They traded long-term warranty safety for the urgent ability to simply drive to work. And now, everything you have learned finally comes together for number 1, the pedal hold reveal. If you search transmission reset on YouTube, a million videos will tell you the exact same secret. Turn the key on, press the gas pedal all the way to the floor for 30 seconds, turn it off, and release. The entire internet absolutely swears that this clears your transmission's adaptive memory. And the crazy part? It actually works. You drive away, the throttle is sharper, and the sluggish shifting vanishes completely. You feel brilliant. But the devastating truth? You did not even touch the transmission. This procedure is entirely an engine-level recalibration. Remember that electronic drive-by-wire throttle plate we talked about from Trick 8? Well, holding the pedal simply forces the main engine computer to relearn the 0 and 100% physical endpoints of your gas pedal. It merely sharpens the throttle mapping. Because the engine now responds faster to your foot, it sends a highly aggressive torque spike signal to the transmission. The transmission detects this sharp torque data and immediately commands a firmer, faster shift. Your shifting improved purely because the engine input changed, not because the transmission wiped its memory at all. Except for that bizarre Mazda anomaly in Trick 4, a pedal press simply cannot touch a modern transmission without a professional scanner. The Ford EcoBoost community proves this with their own unique version. With ignition on, they slowly press the pedal to the floor over 10 seconds, then release rapidly, repeating 3 times. F-150 owners absolutely rave about the eradicated dead zones and pristine initial acceleration. But again, it solely recalibrates the engine-side throttle geometry. Millions of drivers perform throttle resets while falsely believing they have cured their dying gearboxes. If your transmission has severe internal clutch wear, the pedal hold is a very dangerous placebo. That snappy throttle response makes you smile for a week, while the transmission silently goes right back to tearing itself apart. The ultimate golden rule of automotive repair is incredibly simple. Use data, not myths. Look at your fuel trims. Check for vacuum leaks. Ensure your battery voltage is perfectly healthy, because the most advanced supercomputer on Earth simply cannot outsmart a broken mechanical part. And now that you understand exactly how your car's brain works, you need to know about the one bad habit that silently destroys your $1,200 catalytic converter before 70,000 miles. Most drivers have no idea they are doing it every single day. That video is right here. And if you want to know the one part that silently causes most engine misfires and 99% of drivers find out way too late, that video is right here too.